focus on awk. Now, in contrast to grep, awk is a field processor. It delimits by space or white space by default, which means if items are separated by a single or more spaces, including tabs, then awk will return that information using a series of variables, numeric variables, $, which are accessible via $1, 2, 3, and so on. So awk is a field processor. It's very important because all along we've shown you how to use grep to extract lines that match at some point in the line, but how about actually extracting columns within those lines? So with that said, let's create a section labeled awk and describe awk's features as being 1, a field processor, and 2, the fact that it supports egrep compatible regular expressions, which means it's POSIX compliant. So awk is an egrep compatible program, meaning any of the regular expressions that you may have created for egrep, which means you've run it through grep with the E option or by indicating egrep explicitly, will be supported by awk. Again, it's a field processor, a column processor, field/column processor. It also has the ability, like grep, to search for matches on a line and return the entire line if that's what you want. So it can behave like grep. So it can return full lines like grep, based, of course, on matches. Now, here's some usage information for awk. General usage includes the following: awk followed by an optional match, so optional match, followed by an action to take. And an action is usually indicated between curly braces as follows, and everything is usually included between, with the exception of the file name, to parse single quotes. So you'll find that awk commands usually resemble the following, followed by the file name, or optionally stdin or pipe, usually pipe, since stdin usually means it comes from a file. So as an example, let's say we wanted to search for, or just return initially then search. So we want to return column 1, or the first field, from each of the lines in the grep1.txt file. So we'll awk, and instead of indicating a match, we'll just go straight to the procedure, whereas we'd normally specify the match here, and the match is usually specified between regex characters, the / characters. So we'll awk print column number 1. Now, the reason why we're using single quotes here is to ensure that the bash shell does not interpolate $1 to mean a variable that's maintained by the shell. So use single quotes to avoid interpolation by the shell. We'll note that in a second. So we'll print column number 1, terminate using curly braces and a single quote, followed by the name of a text file, grep1.txt. Let's just note, use single quotes with awk to avoid shell interpolation of awk's variables. Very important, otherwise you may find that you end up with unexpected results when parsing columns or records from a file. So here's grep1.txt. This is a perfectly suitable text file to us, or for us to execute our awk command against. So we'll reset, Control-Shift-V, and go ahead and try to put, and we're in the wrong directory here, so we'll change back into LinuxCBT's home directory and try it again. Now let's try to do a search. It should be in test RH5, that is. We logged in as root for the sole purpose of being able to access the / system log file. So here we see the first column being printed, but you may wonder, well, it doesn't look any different from the source file. And that's because each of these, with the exception of CBT space Linux, has only one column. And in the case of the line which contains CBT, notice it didn't print the Linux field. So in this case, it prints only field number 1, whereas if we wanted to see, let's say, print number 2, see field number 2, we could indicate number 2, and only the line which contains 2 columns would print. For everything else, a blank is printed, with the exception of the CBT space Linux line. So you can print distinct columns by indicating the number of the column using $sign followed by the number. You may also print multiple columns by simply indicating, separating the columns with a comma, any number of columns, so such as the following: $1, comma, $2, and you may also reorder the columns if you'd like. Let's give this a chance here, and this will print the document the way grep would if we were to tell it to grep anything or to grep all things from the file. So you can reorder this output by changing the order in which the columns appear, and now you see that column number 2, which is a space for most lines with the exception of the CBT line, is printed followed by column number 1. Also, we should note that awk automatically assumes an output field separator. The default input field separator is space, and the default output field separator is also space, or white space. So note, default input and output field separators is white space. And this can all be influenced, and for a much deeper coverage or information regarding awk, you should take a look at Linux CBT awk set edition, where we dig into the influencing of the different variables that control the awk environment. But we're going to move on to show you some other things you can do with awk. So this is basic usage. You can rearrange the columns, and as we've told you, as awk reads lines, it stores the columns into different fields. This is what's called tokenization, where awk reads the input and it stores the entry into a token. Token number 1 represents the first column, token 2 represents the second column, so on and so forth. In the case where the second column doesn't exist, then the second column is simply a white space. You may also change the delimiter of your input file and change it on the command line as well, and awk will have no problems once you specify what the delimiter is, parsing that information. Now how about searching for specific lines? Let's look at grep1.txt again. Supposing we are interested in lines containing Linux. So, a simple search, awk, everything is going to be between single quotes, and we must specify our items, our procedure items, our action between curly braces, so this will hold our action. But now we have a match. We have a pattern that we'd like to search for, and we'll indicate the pattern between the regex characters. So let's say we want to search for Linux CBT. We'll go ahead and indicate Linux, or Linux that is, on any of the lines. This will search for lowercase Linux on all the lines, and when it finds it, it's going to perform the action that we indicate. So let's indicate an action of print the entire line. Now, if you'd like to print the entire line, it's quite easy, just like you were able to do with grep. Simply indicate print with no option. Now let's just indicate that this will print all lines containing Linux as a keyword, and that's lowercase Linux. It's a case-insensitive match. We can alter the case, and we'll show you how to do it momentarily. So let's try this from the shell. We'll reset the buffer, and there you see it prints the lone line which contains lowercase Linux. Searching through this document, there's only one line which contains lowercase Linux for it to search through. Now back to the notion of printing case insensitively. If you search a document, for example, using the I option, and we indicated lower, let's return and just change that briefly, uppercase I option, you'll see that it searches the document for various instances of Linux, and that's how it searches it. So it throws those lines that have matching characters in our search using uppercase I as an option. It will also print other options as well. You may also search for lines that contain various character classes. So instead of case insensitive, for example, let's say you're looking for lines that contain Linux CBT in alternate cases. Here we have one entry. Let's make a separate entry. We'll make it lowercase. In the case of CBT here, this will be CBT3, and then give this a try. So using character classes, we can search each of the characters, lower upper C, lower upper B, as well as lower and upper T, and this will search the document for any such items. But of course, the case insensitive option is turned off. So if, for example, the items are indicated using a different case, such as uppercase Linux, then we can specify that as well, or character class the entire thing. Now it returns both of the lines, and it prints the entire line for you. If you indicate no match, it prints the entire line without matching, and if you indicate something to match on, then it will function as a condition to print items that are related to that line only. You may also make optional the CBT trailer. So for example, if we wanted to search for CBT not using character classes but as a group, then we can indicate the group between parentheses as opposed to square brackets as follows. CBT, this would search for the block after the word, and of course if the case matches, it'll return. And we can indicate any number of matches for this block of characters. We can also turn on case using the uppercase I option. So there's a wide variety of ways for us to search for information in this document. For example, we could return lines or print lines where in column number 2 there is the entry Linux. So let's show you how that would work. This is a conditional search. So awk, and in our search, we'll open curly braces here and indicate using a condition if column number 1 using the tilde symbol is equal to this match, then we're going to perform the option, or the action that is, to print from grep1.txt. In this case we said column number 2. So if column number 2 is equal to Linux, let's just check the case, otherwise we'll have to turn on case insensitive. So if column number 2 is equal to Linux, then print the entire line. Then we'll create a variation on this momentarily to print column number 1, column number 2, as well as both of them. So in this case, it prints the entire line for a line which contains Linux in the second column. We may also print, let's say, column number 1 if column number 2 equals Linux. So let's print number 1. There you see it prints only 1. We may optionally print 2 then 1, but we can mix and match the data however we see fit, and we can also change the output field separator so that there's no space or a comma, or change the delimiter, so on and so forth. So it's this sort of flexibility, the ability to behave like grep as well as not like grep by focusing on fields, which is what makes awk so special. We can conditionally search for information. We may use regular expressions, and it works pretty well. Now, great usage of this conditional feature is to search through log entries for specific items. So let's create a 6th option here. So we may want to search the messages file for something particular. Let's go back to our root session, our root shell, to var log messages. Let's say we want to see from this messages file, from, let's say, the second field. The second field represents the day. In this case, it's the 8th. Let's say we want entries only from the 8th of the month, or the 9th, or the 7th. We could say where column number 2 is equal to 8, return the full line, as opposed to grepping for January space 8. Sometimes it doesn't work if the number of spaces are unequal from one line to another. So we can do a search like this. If, and in between parentheses, column number 2, tilde, regexes, equal to 8, then take an action. That action will be to print the entire line from the file, of course, var log messages. We'll just note that this will print the entire line for log items for the 8th of whatever month. If we need to be more specific, such as month and day, then we'll need to match also on the first column, which includes the month, in 3-digit form or 3-letter form, 3-character form. So now we see entries only from the 8th, regardless of daemon type, represented, because now we're matching column number 2, because again, when awk reads the messages file, it stores January into token 1, 8 into token 2, this full timestamp of, let's say, 9:09 a.m. and 41 seconds into token number 3, the server name into 4, the daemon and process ID into 5. So long as there are no white spaces between the items, they'll be stored into the same token, or represented by the same token. If we wanted to see items from the 9th, then just change the regex to be the 9th, and now we're matching on the 9th. So it's again this sort of stuff that we're able to do with awk that you cannot do with grep. The ability to tokenize and expose those tokens, or expose all the tokens as they are represented in the original file. And awk, just like the other tools, can accept its information on standard in. So we can grep, let's say we grep from this particular document sys, or we'll go with SSHD entries from messages. This returns only SSHD, but SSHD has entries on the 8th and the 9th of January. So now we pipe the output into awk, and we tell it what we did here. Let's just copy this to save us some time. We don't need the file name whenever you pipe the information, as the information will not be received from the file, but rather on standard in from the previous command. So we'll grep to filter the output, the standard out stream, which will become the standard in stream for awk. We'll filter it using grep to only SSHD records. Then awk will match column number 2, and if column number 2 is equal to 8, then we'll filter out the record for the 9th, or any other records for that matter. And there you see now only records for the 8th. So again, another neat way to use piping and two popular utilities, grep and awk, to zero in on specific items. Now of course we could have grepped directly for items from the file that are from January 8th. So we could grep jan 8, jan space 8, from the messages file. This will return all the daemons with jan space 8. But if you notice, this didn't work. That's because often there's a leading space holder for multiple values that are 10 or greater for the month, for days that are greater than 10 or greater, that is, greater than or equal to 10, which is why you need to include an extra space. So it's a little tricky, whereas with awk you could simply say for the second column match it on 8, regardless of how many spaces exist between the month and the day. So again, another advantage to using awk, but we could grep January 8th and then pipe the output right back to grep using even different delimiters this time, or using different quotes, that is, this time, searching for double spaces 9th, and this would filter the information to January 9th in the event, well, we grep for 8, so let's grep for SSH now. And this now returns only SSHD instances, and we could further parse the information. For example, we could present this to awk and tell awk to take out column number 3 and then break up the items. Let's take a look at that. So our 7th task will be awk, and now we're going to focus in on column number 3 in the messages file, because we know that column number 3 contains the timestamp information regardless of the record. A standard syslog entry includes the month, the day, and a timestamp. So that means we can print column number 3 regardless of the daemon from var log messages. This is our first step. Let's just ensure that this works, and whenever you're building these commands, just do it one step at a time to be sure you're doing it properly. So here are all of the timestamp entries from the file for column number 3. Then you could zero in further on column number 3 by piping the output back into awk and changing the field separator this time to colon. If you notice, the time is delimited using colon as opposed to period or semicolon or some other delimiter like /. So now we tell awk that the field separator is colon using the -F option, and now again we'd like to take the action which follows to print, let's say print everything. And then after we print everything, we'll zero in on the individual time components, including hour, minute, and second. Now let's just check we missed a single quote here. Now we see everything. So we want to take it a step further. Let's print number 1. This will indeed return only the hour part of the time, leaving the minute and seconds unavailable. You can compare and contrast. Notice the last entry is 22 for 2200 hours. The first entry is 10 for 10 a.m. And we can continue to re-represent the time by printing only those columns that are of interest, such as 1 and 2. Now we've got hour and minute. But also note again, awk has its own output field separator. So as a result, it separates the time on output using space or white space instead of the original colon. To re-represent the original colon, you'll need to influence the output field separator by setting the OFS variable in the begin section provided by awk. Awk has a begin, middle, and end section. It operates using those 3 sections, and as a consequence it allows you to run things before, like a prescript, similar to Kickstart when setting up Red Hat Linux, during and after. We should also note above what we just mentioned. Awk runs 3 steps. A is a begin section, B is the body where the main action or actions take place, and 3 is an optional end section. So both the begin and end sections are optional, but the body where the main action or actions take place is required. So far we've shown you single task items or actions such as print $1 or simply print. You can execute multiple actions by separating the actions using semicolons. So let's just note that multiple body actions can be executed by separating them using semicolons. For example, you could first print field number 1 and then on a separate line print field number 2 and then close your curly brace, and these 2 are considered distinct actions and they'll both execute as awk loops through its input. We should also note that awk auto loops through input stream regardless of where that input stream is sourced. So regardless of the source of the stream. And the examples given here include stdin, which usually comes from a file, pipe, and will indicate file separately. Because with standard in, we mean, for example, you could execute awk and it waits for you if you don't indicate a file for standard in. For example, let's simply execute awk in between curly braces, print the entire line given, or let's print column number 1 and terminate without indicating a file. Right now awk is waiting for us on standard in. It expects input, so we need to supply it with input. We'll give it a test here, Linux CBT. And notice it prints column number 1 as opposed to column number 2. Let's try CBT Linux. And as you can see, it prints column number 1 instead of column number 2. So for each line of input, awk evaluates and executes its actions. In this case, the action is to simply print $1. When you've completed your input stream, execute Control-D and that'll terminate the awk session. Now back to multiple actions. Again, we can print 1 and then print 2. Now we give it back to what we did before. And notice it first prints Linux, delimits, that is, using a new line, then print CBT. Both actions occur on separate lines. Let's try CBT space Linux, and there you see it prints line number 1, then line number 2. So you can combine any number of actions to be performed by separating them by using semicolons, or you can use commas to indicate the fields that are to be printed. But again, awk supports different types of actions, primarily the print action, but there are other types of actions. And it also supports begin and end blocks. The begin block is a way to set variables such as your input field separator, output field separator, input and output record separators, so on and so forth, all of which can be set in a begin block. The end block is usually reserved for summarization, for reporting, for tallying up totals for the amount of records processed, or for reporting on those totals, for example. But again, for much more information on how awk is able to do all of its wondrous things, take a look at Linux CBT awk and sed edition, where again we delve in and get into the meat and potatoes of awk and sed over a good amount of time. So with that said, we're going to move on. We're going to be taking a look at sed, since we've spent enough time, in my opinion, covering the basics of awk.